This problem is saying graph the function h of x and then state its domain in range. First, let's establish the parent function and then graph the parent function just so we know where to start. So that's our parent function. Now let's talk about the type of transformations that are involved in this h of x function. We know that if it's under the radical, we have a horizontal shift opposite this sign. If we're adding or subtracting outside the radical, we know that we're going to have a vertical shift, and it follows the sign. Now we've got a few extra things out here. We know that this symbol, since it's outside the radical, that's going to be a vertical movement, so it's a vertical reflection. And then the last piece is this 2 right here. This is telling us that it's a vertical stretch because it's outside the radical. And we'll just say by 2. So let's start by graphing the starting point. Starting point will be left 3 and up 6. If we had no stretch and no reflection, we go to the right 1 and up 1. But since we have a reflection, we know we're going to the right and then down. And since we have a stretch by 2, we're going to the right 1 and down 2. And then the next point, we're still going to go over 4. But instead of going down only 2, we're going to go down twice as much. We're going to go down 4. Now it's easiest to do the domain and range from my graph. My domain, I'm talking about the x's, so I know that it starts at -3 and it's everything greater than -3 goes to the right. So we can say that x is greater than or equal to -3. You can see in the y direction, range talks about the y's. We can see we start at 6 and it goes down from there. So all the y's are less than or equal to 6. So there you have our graph in red, and we've got our domain and range.